So why wood? The timber or wood, it's very easy, cheap, and light to work with, and building with wood is efficient and fast. Some wood elements can be prefabricated off-site and delivered swiftly to the site. Wood also has a higher insulation rating than either steel or plastic as a result of its natural cellular structure. This means that homes and buildings require less energy to maintain heating and cooling. And in Canada, it's very cold. Most of the time of the year, we need heating inside our buildings. One of the biggest challenges of many building materials, including concrete, metal, and plastics, is that when they are discarded, they take an impossibly long time to decompose. When exposed to natural climatic conditions, wood will break down much more quickly and actually replenish the soil in the process. With a wide variety of species available, wood presents an incredible range of aesthetic options, as well as provides varied mechanical, acoustical, and thermal properties. Now, Canada and wood, the Canadian forest sector is a major employer nationwide, and its economic contributions are particularly evident in many rural and indigenous communities. Most of the lumber we produce here in Canada is exported. Less than 40% is consumed domestically. Since the mid-19th century, the United States has been the most important buyer of Canada's lumber. So that means we have a very large amount of benefit in our economy. Now, there are two major types of construction systems we do here in Canada using the wood. So one is the light wood frame construction system. And what is that? This is like you can see by seeing the image here. It's a small scale project. The wood we use here, we call them dimensional lumber. By the way, when I call it, and several times you will say that I am saying lumber. So lumber, same as timber or wood. In North America, we use that term, lumber. So for this light wood frame construction system, what we use is the dimensional lumber, and those are pretty much natural. Just we cut down the trees and we get the wood and we cut them in our desired size, and do a little bit of preparation for like the moisture content. We take out some moisture. We keep a certain amount of percentage of moisture in the wood, and so that is dimensional lumber. And then those are regularly spaced, those members, wood members, and fastened together with nails to create floor, wall, and roof assemblies. We mostly use this type of construction system in residential and small-scale retail, office, or commercial building. We can go up to 6-story buildings with this light frame construction system. Another type of construction system using wood is the heavy timber construction system or mass timber construction system. So in contrast to light frame wood construction, it is built using engineered wood products. That means we do some fabrication. We make the products in factory using those natural woods, and then make very strong wood elements and made of large solid wood panels, columns, beams, and often manufactured off-site for load-bearing wall, floor, and roof construction. So this mass timber or heavy timber is engineered for or fabricated for high-strength ratings like concrete and steel, but are significantly light in weight. Mass timber can complement light frame and hybrid options and is a very environmental friendly substitute for carbon intensive materials and building systems. So the new 2020, our National Building Code of Canada, that says that we can go for up to 12-story structures using this mass timber construction system. Okay, so now I will talk about the light timber frame construction system today. And I will talk about in terms of an example, a case study that is Catalyst House. And this house is a 1.5-story bungalow. There is an can see the floor plan. It's a very simple, actually 4-bedroom house. When 2-bedroom goes upper floor, and 2 on the main floor. We have living, dining, kitchen, a small office, and an attached garage with that. So the upper floor is not fully the full. It's taking the floor space. It's just the partial floor space. So when we will start, explaining the construction process, wood construction process, definitely we need to start from the very bottom, the foundation. Even though we use our framing is of wood, but the common or standard procedure is like we use concrete for the foundation. And as you know, Canada's temperature gets very low during winter, and our soil gets frozen sometimes. Then again, like when the temperature rises, those icy soil that gets melts. So we experience kind of like a swelling and shrinking of soil, and that phenomena we called frost heave. And the result of this is you can see the cracking and bending of the foundation, that concrete foundation wall, and the footing also. So but at some depth, like if you go dig a little bit below, then you could see that the soil at that point doesn't change much temperature. So it is like kind of uniform in temperature at certain levels. So what is that depth? We call that frost depth. And the height or depth is like in Calgary where I'm living, it's kind of like close to 4 feet. By the way, we here use all imperial like feet and inches system because United States, they use that. So we, Canada, we do use that, but we are in between both systems. We use both metric and imperial systems, but for residential, mostly we use imperial systems. So when I will go through today, like, I will talk in terms of like all imperial units, all feet and inches. But for the commercial buildings, we use metric systems. And so here, like we have to dig at least like 4 feet for our foundation, even though it's a very small scale building. But then we see that, okay, if we are digging 4 feet, why not dig a little bit more? So then we can use that space below ground, like that area for livable area. So that's why you will see that most of our houses, or mostly houses in cold areas, we have basement. So that is one of the reasons why we are having a basement, because we have to dig that much. And we call that frost line. So always we have to dig or start our foundation below the frost line. And this is a picture of image of like a common or standard foundation system here, even like for our whether it is residential or other type of small scale wood, light wood frame construction. And this house, as I said, we have an attached garage. And you can see like a same kind of foundation system we do for the garage, like spread footing and concrete foundation wall. But for the garage, we just make a shallow foundation. We don't need to dig that much because we don't need to have a basement there. But definitely we should do at least 4 feet because the frost line. So that is the common type of foundation system for the garage we use here. But can we do the foundation with the wood? Yes, we can do the foundation, not only the concrete, but wood can also be used for the foundation system. But in that case, we have to do a special kind of treatment for the wood, and we call it pressure treated wood. Yet we put certain chemical coating on the wood because, like if wood comes into contact with the soil, because soil has moisture, it has some organic materials that can let the wood decay and rot. So to prevent that, we can use the some kind of treatment. We call it pressure treated wood. But this is not so popular because it takes a little bit and cost wise also it's a little bit costly, and concrete that way is very easier to do. So once we're done with our foundation system, now it's time to start with go upwards and do our wood framing. So above the concrete foundation wall, everything is wood. So we have two systems for our wood framing. One is the balloon framing and one is the platform framing. And what's the difference between that? These are all wood. Yeah, this is the foundation, concrete foundation wall, and on top the wood framing. So the balloon framing you see here, the walls, these are the walls. So walls are continuous from the top, like from the bottom till the roof. The walls are continuous, and then we insert the floors in between. Whereas platform framing is like how we do is we do the floor and then we do the wall and then again we do the floor and then we again go to the wall and then roof, and if you have another floor, same process repeats. So that is the main difference between the balloon framing and the platform framing. In our house here, the house I showed you, we use the platform framing, and this is very common and standard practice here. The main advantage is in terms of load distribution, strength, and stability of the structure. But how we will start our wood framing? So we need to prepare our foundation, the concrete wall, to attach or to start the wood framing on top of it. So I'll go through the steps for framing the whole house in order. The very first step is to prepare the top of the concrete foundation wall for wood framing, and to attach the wood floors. We put a wood piece. You can see here a piece of wood on top of the foundation wall, and we call it sill. There are two ways, two different types of sill we can do. One is just a piece of wood goes on top of the concrete foundation wall that we call mud sill. Another thing is, another option is ladder sill, and you can see that it looks like ladder. Yeah, there are those horizontal pieces, and this ladder sill is embedded into the concrete foundation wall, and this one just sits on top of the concrete foundation wall. In this house, we used the mud sill. So now when the mud sill is done, time to attach our floor framing. So to do that, first of all, we attach this vertical piece, and we call this, like on the floor framing, this horizontal, this vertical pieces, we call them joist. And this vertical piece is, we call them a rim joist or rim board that goes all around our house, and it sits on top of that mud sill that I showed you in the previous slide. And with that, we attach all those horizontal pieces. Those are joists. So that's how we create the floor. We do the floor framing. And to talk about the joist, there are two types of joists we can use. One is this, at the very beginning, I told you the dimensional lumber. So that we just get from the tree, we cut down the tree and get the wood and do some treatments, and then we use right away. So that is dimensional lumber. Option is engineered. That means these are totally made in the like the wood chips and wood panels, and we glue them together, so we give them certain strength, or they're stronger. So those are made in factory, so we call them engineered joist. And because this is very common practice nowadays, we use the eye joist because it looks like eye. And so these are two options for these joists. either one is fine. And in terms of strength, it's fine. There are some advantages of the engineered I-joist, but otherwise both are the same. So with this vertical piece, rim joist, we attach all the joists. We attach there, we use a certain kind of metal hanger to attach the joist, horizontal joist, with that vertical joist. And here in this picture, you see at the edge, we use some kind of insulation, you know, because we have a very cold weather here, so we need to keep warm. We'll talk about a little bit insulation later on. Now that's how the floor framing looks like with the wood. And to hold the joists, those horizontal members, we put, it needs support underneath. So we use beams underneath. And of course, the beams are being supported with the post or columns. And columns had the same kind of like a footing, a concrete footing that goes below ground. For the floor framing, whenever we have the floor, we must create some kind of opening, because the one can be for the staircase. So whenever we are creating an opening, we are making the whole system a little bit weaker. So, but to keep it stronger, what we do is we install double joists all around the opening. No matter for what purpose the opening is, whether it's for staircase, whether it's for any other, like like double height space, we create a large opening. So sometimes double, maybe triple joist all around to keep it stronger. Once we are done with this floor framing, now we have to install something on top of it to cover. So these wood panels, these wood panels could be mostly here, commonly we use plywood and or OSB. And the thing is the joist spacing, I'll talk about a little bit on the joist spacing, like center to center. We use either 16 inches or 24 inches. You know, here everything we have those modular, all are set up like those distances, those dimensions. And we just don't go to any random numbers. We have to be very specific with these numbers, because, you know, like the joist spacing depends on that. Those comes also in a definite size. So these panels we get 4 feet by 8 feet. So then when we put the panels, the end of the or edge of the panels sits on top of the joist, not somewhere in between the joist, because otherwise, you know, like two panels are joined together and it will be bent. So that's why we make sure that, because we get those 4 feet by 8 feet, no matter horizontally or vertically, we place those panels on top of the framing. The edge of the panel should sit on top of the joist. And what we do is we put first very strong adhesive or glue on top of this joist, and then we install the wood panels on top of it. Yeah, that is the one piece of wood panel. Okay, so floor framing done. Now time to do the wall system. It's very fast. The whole process is very fast. That's why that is also another good reason to use the wood system, wood construction system. So to do the wall, what we do is the same kind of, see the framing like we did for the floor. Here, all the vertical members. For the framing, floor framing, we call them joist. For the wall framing, we call them stud. And the size is, like we have two different sizes, one for exterior walls and one for interior walls. These are for exterior walls, we use in this way 5.5 inch, this way 1.5 inch. For the interior wall, same 1.5 inch, but here it's a little bit thinner, 3.5 inch. So what we do, the whole thing, the framing on the floor, and then we lift them up and put them vertically on place. This is a standard wall framing. And you would see the same kind of like the spacing we use as we used in the floor framing here also for the walls. Same process, 16 inches or 24 inches center to center goes. And wherever we have the opening, like in the floor framing I showed you for the staircase, we have to keep it stronger, the staircase opening, around the opening. So here also, whenever we create the opening for any doors or windows, so we have to do extra, we have to be extra careful and put like double studs around the doors. And the lintel for the top of the doors and windows, we put a little bit larger piece of wood. So that's the a common wall framing. So that's how, like when we first put the wall vertically, and we put a little some brackets or braces for the support, initial support, but then we remove them. And these are the interior walls, 1.5 inch by 3.5 inch studs. And you see at the bottom, we put one like a bottom plate, and then the top, usually we put two horizontal members. We say top plate and cap plate. Okay, so wall done, floor done, wall done. Now we have to, okay, one thing I need to mention here also, like on the floor, on top of the framing, we put those wood panels. So the same way, outside of our wall, this vertical stud framing, we also use those panels you can see here. So those panels, the same materials like either plywood or OSB we use, and those also come in the same size, 4 feet by 8 feet. So all like modular, and so that's why we also here we need to be cautious, like make this keep those spacing either 16 inches or 24 inches. So then the edge of the or end of this panel should be on top of the studs, not in between the studs, for them to the panels to be attached with the studs. Then it will be stronger. Overall process are all same. The floor, the wall, the roof. Only like we have different sizes of the framing members, and the names are different. For the floors, we call them joists. For walls, we call them studs. For the roof, we call them truss, because we make all, like we have the sloped roof, and those trusses mainly nowadays those are all engineered, like we create according to our design, like whatever the slope we would like to have, and we give the manufacturer our drawings, and they, seeing our drawings, they make the trusses for us. It's up to like whatever design we give them, they can make that those trusses, and those are very strong trusses. Those are prefabricated. We just make them in the factory and then deliver to the site, and with the help of the cranes, we install them on top of our house. But we also make the trusses on site, but that takes a little bit of extra time and then wastage on the site. So, and it needs expertise to do that. So that's why nowadays we avoid that. We just all are prefabricated. The trusses are being done in the factory according to our design, and then just delivered to the site and installed on top of the house. So in our house, this Catalyst house, as I say, like our upper floor is just a partial area, and so what we did is the truss we used that covers the upper floor and the lower floor also. So the truss looks like, if you can see the truss here, it looks like that. This is our upper floor area. This is the garage area. For the garage, it's like a simple truss we used. For this The whole house is this kind of truss we used, and we call that piggyback truss. So there are different types of tons of different options of trusses used. We can like make inside like a vaulted or any different sizes and shapes we can do. That's the advantage and beauty of doing them like in the factory, the engineered trusses, and they're very strong. And for the trusses also, the spacing in between the trusses are mostly, we use 24 inches from center to center. And the same thing goes for the roof also. We use those wood panels on top of the trusses. And those are also comes the same size, 4 feet by 8 feet. That's why you will see in the overall, like the whole house, we have those, the framing spaces, the member spaces. Our spacing is 24 inches or 16 inches. And you see here, they are like we put the glue, and on top of that, we install the panels. And then we use, I'll show you somewhere, maybe next slide, how we how we fasten them or attach them with the framing members. So this is how it looks like, the framing part. Then, as I mentioned before also, like for the walls, outside of the walls, we use those OSB or plywood. We call them sheathing. Just the names are different, but the overall process are same. So plywood and OSB, those are the panels we use for the floor, for the wall, for the roof. And one specialty is we use, you see those, the tongue and groove joint. So then they can be attached with each other very tightly. And so here you can see the, on top of the floor joist, we have those wood panels. They have tongue and groove joint in between. And with this machine, it's kind of like a stapler machine, but you need the electrical power to run that. Very strong, very powerful stapler machine. And it's very fast. Like you will be amazed to see like how those construction guys, they do that. Like it's very fast. They just staple the panels with the joist, or same way here with the floor, walls and the roof. So talking about the walls, like our systems, those are that is the standard framing type. But you know, like we have very cold temperature outside. We need to maintain warm inside. We have heating, and also even with heating or without heating, we need to have certain temperature inside maintained. So that's why we add some layers in our wall system. It's not just the framing. So what we use is, yeah, that's our wood framing. Say for this is a typical wall, and we use insulation in between. So that is another another reason why we use the wood framing, because we can put insulation inside. Because if it's just think of like it's like the concrete wall, but then we need to put extra insulation, extra wood framing. How would the cost will be very high. So that's why it's very, and it will be very heavy, like if we use concrete or brick. And for the wood, it is light at the same time, and we can have insulation embedded inside. And then on top, we have those plywood or OSB sheathing. And then with the help of these wood pieces are for like when we use our finish material, whatever it is. It could be brick, just like the finish. It's like a very thin pieces of brick, or could be stone, or could be very common is we call them siding, the horizontal pieces of vinyl or wood for the finish material. And so we attach them. And inside, from inside of her room, what you see will be, it's like a gypsum board. We call them drywall. So those are all the layers. And sometimes we also use extra insulation on top of our that layer. So if we use 2 layers of insulation, that will give us better result in terms of to keep our inside warm. So that is a typical exterior wall, the wood framing wall. This is a typical basement wall. If we are using the basement for because livable space and just only concrete wall, it will make you very cold. So that's why we use another small, it could be like that 3.5 inch, not thick as the upper exterior wall. So that wood framing goes inside and insulation, and inside the gypsum board or the drywall. So that is the typical basement wall detail. And we also use insulation underneath our basement. So basement floor is concrete, and we use the insulation, 1 extra layer of insulation. And that insulation is like, like the foam board. We have different types of insulation. Like this insulation here is on the exterior walls. Those comes as like a thick layer of blanket kind of thing. Those are made of different out of different materials. But we put extra, and wherever we have our building system separating from inside to outside, we use the insulation even in the roof. You can see here the roof, these are the roof framing, the truss, and the insulation. Here, this pink thing is the insulation. And whenever we have like in our house, our roof is like that. When we have the living area in that, or like we call them attic area. So in that case, we use the insulation like that. But the thing is, we must have insulation still there. And that is our inside. Again, the same way that drywall or gypsum board we use inside. So the whole system, the construction system won't be complete if I don't talk about the staircase a little bit. So the stairs, yeah, all wood, as you see. And the what we do is in this house, the Catalyst house, the stair is this, like the L-shaped staircase. Yeah, we can do any kind of shape. But the thing is, we first, do the, like the other, like the common way, like we measure the height from this floor to the top of next floor. And then we do the calculation, how many steps we require, because, and also we need to follow our building code, what our building code permits, like what would be the maximum and minimum height of each step or the width of each step. And then considering that, we create just 1 flight of staircase outside, and everything is done, and then we install it here inside. And the landings, for the landings is the same way as we do our floor framing. So also like the same way, the horizontal, those floor joists, and the rim board kind of like at the edge, and then those are prefabricated or can be done on site and then attached with the landing. So that's how we do our staircase framing. Now, because ours is a very cold climatic zone, so we have some challenges, and one of the biggest challenges to keep inside warm, and we need to put the barrier so that like outside cold air should not anyhow should not get inside, and inside warm air should be warm inside, not go outside. And so we need to maintain an uniform, even though we have heating system, mechanical heating system, but still we have to maintain a certain temperature inside. And to do that, we use insulation. And when we choose the materials, you know, the thermal resistance or R value, that is the main concern for us. We choose whatever materials we choose, we need to see what is the R value of those materials. The higher, the better. So the insulation gives very, very high R value. And even like those plywood, the OSB, and whatever materials we use, the reason behind is that we have higher R value. Even the wood that has very high R value than brick. So that is another reason why we use the wood for our this cold climate construction system. Now, when we use the insulation, another challenge comes is the moisture can be trapped inside. So because we inside, we have warm air, we also create moisture, right? When we cook, when we wash, when we take shower with the warm water, the moisture is being created. And those moisture goes to close to our walls, to our roofs. So, and we have the insulation, and what happens is that the insulation can get wet, and then it will be damaged. Eventually the whole structure will be damaged if it's getting wet day by day, day by day. So that's why what we do is we put polyethylene. You see here, this first image is the typical wall from inside. We can see here. So those are the wood pieces, the vertical pieces are the wood. And then we have those pink things are the insulation. And inside the insulation, we use the polyethylene as the moisture barrier, vapor barrier. So it doesn't let the moisture to make those insulation wet. And also, like talking about the challenges, there are, because we have multiple layers of materials, there may be a possibility of chance of leakage, air leakage, which we don't want. We need to make our whole system airtight. And that's why outside of our building or the wall, we use some kind of air barrier. We call it building paper. It's kind of building paper, but not like the normal paper, but it acts as the air barrier. Like I always give the comparison with our in cold climate, we have to wear the jacket, and that jacket is made of that material that is acts as the air barrier. It's like a like the nylon kind of fabric, and inside we have those insulation kind of thing, or like the sweaters. Those are insulation, but only sweaters cannot help us because it's very cold. Yeah, like air can pass through. So we need that jacket that acts as the air barrier. So in buildings, same thing. Like this air barrier, this building paper that acts as the air barrier. It doesn't let any kind of air to pass through. We need to make sure, that's where we do the overlapping of those building papers. And some other challenges where we have we have the snow on the roof. We have lots of snow, so we do the sloped roof. That's why, and provide proper roof drainage. And I mentioned at the beginning, we have the forced heave, that like the swelling and shrinkage of soil. So that's why we go below the frost line. And we use the pressure treated wood whenever we have close contact with the soil. And this is you see the insulation polyethylene underneath. Wherever we use insulation, we use the polyethylene for the moisture barrier. So now I will show you, I'm almost at the end of my presentation. This is the very small 2 minutes animation clip, and this shows the whole construction process. And this was done by one of my students. This was a class project where I told them to and showed them how to create the animation for them to understand. It is very easy to see this the whole process in this animation, and it is done in Google SketchUp. Okay. somehow. God. Okay. Okay, so if you have any questions now.